All right, so welcome to our Post-UTME sessions. And in these Post-UTME sessions, we are going to be focusing on Post-UTME questions that has been repeating itself in various universities. You know that not all universities in Nigeria write Post-UTME, but schools like UNN, University of Ilorin, OAU, and the University of Calabar write Post-UTME. And this Post-UTME is very, very important because Post-UTME stand a chance of determining whether you really get admission to study a particular course or to get admission to a particular university. This means that even though you can score up to 300 plus and you fail your Post-UTME, you will still not get admission in that particular university. This is to tell you how important Post-UTME is. And in this series, I'll be revealing Post-UTME questions in chemistry and in biology, which I believe is going to also repeat itself anytime you are watching this video. And not just for Post-UTME alone, these questions is also helpful for JAMB students. That means if you're a JAMB bite, this question will really stand a test of time because there's no more difference between Post-UTME and JAMB. And even though you are preparing for your WAEC also, this question is also very relevant because it is all about what? Chemistry and what you are supposed to know at the O level. If you're coming across my YouTube channel for the first time, my name is Basi Ejogba. I'm a 400 level student at the University of Calabar studying medical laboratory science. And in my channel, I have students level up the academic game. I also share full tips on the channel focusing on personal development. So if you love content like this, please don't forget to hit on the red subscribe button so I can continue getting updates anytime I drop videos like this and so that you can help me grow, right? So as you can see on the board, these are some of the Post-UTME questions which my board is not that long. So what I'll be doing is when we finish with this one, I'll clean it and I will write the next question so that you will be going all along. Now, apart from just listening out these questions and the options, I'll be giving you the answer to these questions and also telling you why these options are what wrong. For those options that are wrong, I will also tell you why they are wrong, and those ones that are correct, I will also tell you why they are correct. So without wasting much time, we'll move on now to the first question on the board. The question says, dash are allotropes of carbon. Dash are allotropes. So the first concept there is what? Allotropes, and not just allotropes alone. You say what? The allotropes of what? Carbon. We already know about carbon and its what? Compound. Although I'm going to make videos on this topic, explaining this topic in details. We already know about carbon and its compound, right? And we also know the concept of what? Allotropy, right? So we already know that allotropy is the ability for a substance to exist in what? In different forms, right? But in the same what? Physical what? State. That means it can exist in different forms, in 2 or 3 different forms, but in the same what? Physical what? State. But at this particular point in time, we are not just talking about other elements or other compounds. What we are focusing on is what? The allotropes of what? Carbon. So say dash are allotropes of what? Carbon. We have A, graphite and sulfur. This is A. We have graphite and sulfur. B, we have what? Amorphous charcoal and coke. C, we have diamond and graphite. And D, we have carbon monoxide and what? Coke. So we already know about the carbon and its compound and the allotropes that it exhibits. Basically, carbon exhibits what? 2 what? Allotropes, right? So the 2 allotropes of carbon is simply what? Graphite and what? Diamond, or diamond and what? Graphite. So you get to check through this option. You say what? A, amorphous charcoal and coke, which is not the correct option. C, which is what? Diamond and graphite. And D, you have what? Carbon monoxide and what? Coke. The correct answer there is what? Diamond and what? Graphite. Diamond and graphite are simply the 2 allotropes of what? Carbon, right? And I believe you already know what is what? Diamond, and I believe you already know what is what? Graphite. But in case you don't know, in my subsequent videos, I'm going to be talking about it. So right here with me, I have explanations to why these options are not correct. So let's look at the first option, which is what? Coke, right? The first option here is what? Graphite and sulfur, right? Which is the first option. So for graphite and sulfur, according to what I have here, right? Where is it? I'm coming. All right, I'm coming. All right. Graphite and sulfur. I'm trying to check for the answer, right? I'm trying to check for the answer. It's okay. It says allotropes are different forms of the same element in the same physical state. Graphite is an allotrope of carbon, which we also know. We also know that sulfur, like I said, emphasis is on what? Carbon, right? Because sulfur also has what? Allotropes. So the two, we have allotropes of sulfur to be rhombic and monoclinic sulfur, but that is not our emphasis. Our emphasis is simply on what? Carbon. Why the questions pair them together, while it pairs graphite and sulfur together, the concept of allotropy applies to each element individually, making allotropes the best fit. So that is plenty explanations. Basically, the answer is what? Diamond and what? Graphite. So what we have, which is we have the next one, which is amorphous, charcoal, and coke, right? So for amorphous, charcoal, and coke, these are simply forms of carbon, right? They are simply what? Forms of what? Carbon, and they are not allotropes of what? Carbon, right? Then the next one we have carbon monoxide. We have carbon monoxide and what? Coke. It says carbon monoxide is a compound and not an allotrope, and coke is a form of what? Carbon. So carbon monoxide is a compound and not an allotrope, while coke is not an allotrope of what? Carbon, but rather it is what? A form of what? Carbon. It is very, very important that you follow me up in the series of getting these explanations, you understand, because I need to give you explanation why others are not what? Correct. The next one we have here is a substance is said to be hygroscopic if I'll be making videos talking about hygroscopy, delinquency, right, and desiccants, right? So we said a substance is said to be hygroscopic if A, it does not what? Absorb what? Moisture. B, it is suspended in water. C, it dissolves when it absorbs moisture. And D, it hydrolyzes in what? Water. The answer is what? C. Hygroscopic substances are substances that when exposed to the atmosphere, they tend to absorb what? Moisture from the what? Environment. They tend to absorb what? Water from the what? Environment. And now they don't just absorb this water from the environment, they tend to absorb this water from the environment or the moisture from the environment and dissolves, right? They dissolve when being exposed to the environment, and they absorb this what? Water or moisture from the environment. So hygroscopic substances are substances that will dissolve when it is exposed or when it absorbs what? Moisture by being exposed to the atmosphere. Then let's check out why A is not correct. Why it does not absorb what? Moisture. A says does not absorb moisture. B says is suspended in water. C says dissolve when it absorbs moisture, and D hydrolyzes in water. And let's say the correct answer is what? C. As says it dissolves when it absorbs what? Moisture. For A, does not absorb moisture, it simply is telling you that this is not what? Hygroscopic what? Substance, right? So A, it is the opposite of hygroscopic substance. Excuse me. A is the opposite of hygroscopic substance. Then B, suspension in water is not related to hygroscopic behavior. Please note, I know why I'm reading this point, because this is Post-UTME exam. You may not get to see it the way it is. You may see something like dash is not a property. You understand? That is not a property of what? Hygroscopy or substance, and you later get to see is suspended in water. Hygroscopic substances are suspended in water. It's true or false? In case you get to see something like that, please know that that is what? False, and that is a major reason I have taken my time to write down these explanations, right? So it says suspension of water is not related to hygroscopic what? Substances. And D, which is what? Hydrolysis, or yes, the hydrolysis in water, says hydrolysis involves what? A chemical reaction with water, right? Hydrolysis involves what? A chemical reaction with water, and it is not just what? Moisture what? Absorption. Note that dissolve when it absorbs moisture and hydrolysis in water almost mean the same thing, right? Because hydrolysis simply means what? It breaks down in the presence of what? Water, right? It breaks down in the presence of what? Water. And the same thing here is what? It dissolves when it absorbs what? Moisture. But you have to know that hydrolysis is a chemical what? Reaction, right? And it's more than just what? Moisture what? Absorption, right? So it is very, very important that you know this word. Point number 3 is what? CH3 CO2H. CH3 CO2 what? H plus CH3 CH2OH, right? So these are the two equations that have been given to us, or these are the two compounds that have been given to us. CH3 CO2H plus CH3 CH2OH, right? The functional group here, right? It's functional what? Group. Now the next question I have to ask yourself is what is what functional what? Group. Functional group is what? is a property that tends to determine the reactivity of what a compound, right? The functional group tend to determine the reactivity of what a compound. So in this formula or in this compound that has been given to us, if you're just coming across my channel because of this Post-UTME video, you can get to check out my channel. I've been talking about organic chemistry and geochemistry, breaking them down in details, and I believe they are going to be really helpful. So we say what CH3CO2H plus CH3CH2OH. You already get to find out that this is what carboxylic acid. This is carboxylic acid, and you get to find out that this is what alcohol, or the what ethanol, right? The alcohol, which is also known as the alkanols, or the alkanol, right? So the alkanol, also known as the alkanols, right? It is very important that you understand this. So the functional group determines the reactivities of what a compound. So the question is, the functional group here is A, the alkanol, B, the carboxylic acid, C, the ketones, and D, the carbonyl group. The correct answer there is what B, which is what the carboxylic acid. The answer is what the carboxylic acid. So let's get to see why it is what the carboxylic acid. It says the CH3COOH plus CH3CH2OH. This is what carboxylic acid reacting with what, in combination with what, alcohol, right, which is what the alkanols, right, giving us what is known as what esters through a process of what is known as what the esterification, right. It is very important you know it, that when what carboxylic acid plus what alcohol or alkanols go into reaction, it undergoes what type of reaction or a type of a process that is known as what esterification, and in turn is going to give us what esters, right. Now reacting with ethanol to form what an ester through a process that is known as what esterification. The functional group in CH, right, is the what carboxylic group, is a carboxylic group. Now the carboxylic group is simply what the COOH, right. The carboxylic group is simply the what COOH, and if you get to find out here, you see C, right, and you see what O, which is in what into what 2, right. So this is what simply COOH. So the functional group here, which will determine the reactivity of this what compound, or which will determine the reactivity of this reaction, or how you want to put it, is simply the word carboxylic acid, and not the alkanols, neither is it the word ketones or the carbonyl group. So the alkanols refers to alcohols, right, which is not an acid, right. The ketones have a carbonyl group, right. So the carbonyl group is simply the ketones and the aldehydes, right. The ketones and the aldehyde, which is also known as the alkanols, right. So that is just how it is. So it's not for the ketones, rather it is not for the carbonyl. It says the carbonyl is a broader term, but carboxylic acid is more specific and is correct for this particular reaction, right. So that is just how we for question. It says the gas equation, right. The moment you hear gas equation, it simply means we are talking about gas laws. We are going to bring in gas laws, which can be either the Boyle's law, the Charles law, the Dalton's law, or the Lussac laws, right. So now let's continue with our question. It says the gas equation PV divided by RT equals to 1 over 2n is made up of Charles law. Have you seen? We have our Charles laws, right? It's made up of Charles law and Dash law, right? So what we are looking for, Charles law and it's supposed to be and Dash law. So what we are looking for is the two laws that makes up the gas equation. Now the moment you hear gas equation, what should come to your mind should simply be the ideal gas equation. Please just have it at the back of your mind. The moment you hear about gas equation, don't even think about any other thing. Just think about the two laws that makes up the gas equation. And without looking at the option here on the board, we already know that our gas equation is made up of the Charles law and the Boyle's law. Using the various constants that is being represented in them, we are still going to get this, right? So let's check whether we are going to have our Boyle's law on the board. So we have A, we have our Le Chatelet's principle, right? This is Le Chatelet's principle. The Le Chatelet's principle is wrong. The Le Chatelet's principle is based on equilibrium, right? It's based on equilibrium of masses or equilibrium of objects, right? So our Le Chatelet's principle is wrong. Then we have our Gay-Lussac's law. Our Gay-Lussac law is almost correct. Understand? The Gay-Lussac law is almost correct. It's a little bit related to the, it's a gas law, right? It's a little related to the ideal gas equation, but it is not represented there in the ideal gas equation, despite the fact that it is what a gas what law. So our Gelusa law is wrong. Then we have our what Boyle's law, right? Our Boyle's law is what correct, and we have for Newton's what law. Newton's law is not related to gas law at all. So the Newton's law is automatically what unrelated, and we are not just going to even think about what the Newton's what law. So the correct answer, the gas equation, which is what the PV divided by what R root is equals to what 1 over what 2n is what the Charles law and the Boyle's law, or you can say the what Boyle's law and the what Charles law. These are the two laws that makes up the what ideal gas what equation. Then the next question, which is number 5, says the acid in butter, right? The acid in butter is called, what is the name of that acid that is found in what butter, right? A, we have the word butanoic acid. B, we have the word butyric acid. C, we have the word benzoic acid. And D, we have the word butandoic what acid. So the question is, what is the name of the acid that is found in what butter? So basically the acid, or the answer is what our word B, right? The acid that is found in butter is known as the word butyric what acid. So we are going to check our explanation here to get to see why butanoic acid is wrong, why the benzoic acid is wrong, and why the word butandoic what acid is what wrong. So getting the explanation here, it says the acid in butter is called what butyric what acid, and the butyric acid is the what common what name. It is also known as the what butanoic what acid. It's also known as the what butanoic what acid. So we are going to somewhere, pay note to the acid in butter is called what butyric acid. So the butyric acid is the common name. Take note of this explanation, because this question is a little bit what trickish and very very what technical, right? So the acid is what the butyric what acid, but the butyric acid is known as the what common what name, the common what name. Now this butyric acid is also known as the what butanoic what acid. So you get to find out that we also have our butanoic what acid in the same option. That means some people will now go and choose what butanoic acid, feeling that they are correct, no, the correct answer is what butyric acid. So let's continue with the explanation, right? So the butanoic acid is known as the what the systematic name. So this is what the systematic name, which is also known as the what the IUPAC what name. So this is what the IUPAC what name, right? The butanoic acid is also known as the word systematic or the word IUPAC word name. However, in common usage, take note, however, in common usage, especially in food chemistry, when it comes to what food chemistry, butyric acid is a name that is used and not what butanoic what acid. So the common name, which is what butyric acid, is what is used in food chemistry and not the IUPAC or the what systematic what name, which is the what butanoic what acid, right? So butanoic acid, so the first one, which is the A, so butanoic acid is a what systematic name, but it's not used when it comes to this word context. Understanding the context where a question is coming from will really help you pass that word question. We also have what benzoic acid is found in other word context. So for the benzoic acid is simply what a preservative, right? It's found in other contexts. It's a preservative, and it's not really the acid that is found in what butter in this particular word question, although it is related, because acid, the butters are also what preserved, but in this context the question is being asked. That is why it's very very important to understand the context of the word question, right? So the benzoic acid is known as what a preservative, and it's not what then the butandoic acid, which is also known as what the succinic acid, is totally what unrelated. So the butandoic acid, which is also known as succinic acid, is totally what unrelated to this. So I have a solving here. I have some solvings here. I'm going to clean this off, right, so that I can be able to what solve, right? I can be able to what solve. So this is basically what we'll be solving. Says the oxidation state of calcium in CaCl2, right? This is oxidation state of what calcium in CaCl2. So what we are looking for is what calcium in this particular what equation, right? In CaCl2, which is what calcium what chloride. What is the oxidation state in what of calcium and calcium what chloride? Now if your school is writing Post-UTME, you are in UNICAL, UNIDEL, RSU, UNILAG, OAU, Unilorin, and you are looking for Post-UTME past questions, chat me up on WhatsApp. I have post-UTME past questions on PDFs which you can just get for just 1,000 naira. That means for just 1,000 naira, you can be able to get updated post-UTME past questions for your school, which when you practice them consistently with these videos that I will be dropping on how you can be able to ace your post-UTME on various post-UTME past questions for the various schools, I believe you will stand a high chance of getting admission into the university. And if you also want me to take you on a one-on-one post-UTME class on WhatsApp, then feel free to chat me on WhatsApp. If you want our post-UTME class, which is not necessarily on WhatsApp, we can use Google Meet. Just chat me on WhatsApp and we can get to talk about it. Like I said, I sell post-UTME past questions for as low as 1,000 naira. So let's move on. It says, what is the oxidation state of calcium in CaCl2, calcium and chlorine? Right? We already know that what calcium, right, is a group 2 element, and group 2 element in the periodic table have a special name which they are called the what? The alkaline what? Earth what? Metals, right? The alkaline what? Earth what? Metals, right? So we have the what? Alkaline what? Earth what? Metals, right? Which is what? The group 2, right? Just by knowing the group, right, just by knowing the group, I've been able to get the answer. Sincerely, just by knowing the group of calcium, I've been able to note that they are in group 2, and that is simply the word answer. But let me show you how you can be able to solve for oxidation word state. So we have our CaCl2, right? We already know that chlorine, right, is what? Always what? Minus what? 1, right? So let's assume our calcium is what? Unknown, and let's see whether I am correct to get the alkaline earth metals, which is what? Group 2, right? So let's say this is unknown, right? So we say Ca, right? We say our Ca, right? Our Ca plus, right? Our Ca plus our Ca, this is 2, yeah. So our Ca2 times what? Minus what? 1. The minus 1 is the oxidation number for the what? Chlorine, which is what? Minus what? 1, right? So this is what we simply have equals to what? 0, right? So this is just it, right? This is the 2 that you can see here, and the word minus 1, which is their word oxidation word state, right? So for this, we have our Ca, which is unknown, plus our word 2 times minus 1 is simply what? Minus what? 2, right? 2 times minus 1 is simply what? Minus 2. So we say on minus 2 equals to what? 0, right? So plus times minus is what? Minus. So you can simply say what? You can simply clean this and say what? Okay, to Ca minus 2, right? So we can say Ca minus what? 2. If you want to break it down, you can say Ca minus 2 equals to what? 0, right? We want to make what? Ca the subject of what? Formula, which is calcium. That is what we are looking for, right? So you say what? Ca equals to what? Now, minus 2 will cross the equality sign, right? When minus crosses the equality sign, it automatically turns to what? Plus. So at this particular point in time, what we are going to be having is what? Plus 2. That is how to solve what? Oxidation what? Number. Or that is how we are able to get what? Oxidation what? State. When you hear the concept of look for the oxidation number or look for the oxidation state of this in this what? This. So this is just it. Can see here our Ca plus our number of moles here plus times the what? Oxidation what? State of chlorine, which is minus 1. Where we have our Ca plus or minus 2 equals to 0, Ca minus 2 equals to what? 0, minus 2 crosses the equality sign, gives us what? Plus what? 2. That is just how we are able to what? Get. So let's check the option here. We have A equals to what? Plus 1, which is wrong. We have B plus 2, which is correct, and this they are what? Wrong. So the correct answer there is what? Plus 2, which is what? B. Right. So let's move on to the next question we have there. Let's move on to the next question we have. It says, the mass number of an atom is the sum of its, right? The mass number of an atom is the sum of its A, electrons, neutrons, and protons, B, electrons and protons, and C, the protons and the what? Neutrons, right? The mass number of the atom, right, of an element is the sum of dash A, electrons, neutrons, and protons. B, we have the word electrons and protons, and C, we have the word the protons and the word neutrons. The correct answer without wasting much time is automatically what? C. Now, why is the word answer what? C? Note The electrons, the neutrons, and the protons are what? Atoms, right? Note that in the beginning of chemistry, it was always said that atoms are what? Simply what? Indivisible what? Particles. But as time goes on, the modern atomic theory tells us that atoms can be what? Broken down, right? And when atoms are broken down, we are able to get the what? Electrons, the neutrons, and the what? Protons. Am I correct? Right. So it simply means that the mass number, what we are looking at, we are not looking at the constituent of what? An atom. What we are simply looking at is the what makes up the mass number of this what? Atom, of this particular what? Element, right? So the electron, the protons, and the neutrons, although related, simply does not make up what? The mass what? Number. So this option A is what? Wrong, right? Then electrons and the what? Protons. The electron does not make up the what? The mass of what? The atom. Electron does not make up what? The mass of what? The atom. The mass is simply what? The weight of this what? Atom. The electrons do not what? Follow in order to make this what? Possible, because the electrons are simply what? Revolving, right? The electrons are simply what? Revolving around the what? Atom, and the mass of an electron is what? Negligible. Excuse me. The mass of an atom is what? Electron, right? The electrons, or the mass of an electron is what? Negligible. It does not add anything, right? It does not add anything to the what? Mass what? Number, because it is what? Negligible. You understand? It has no what? Weight. It is what? Light. It has no what? Effect. So therefore, electrons and protons is what? Wrong. And the correct answer is what? The protons and the neutrons, which makes up the what? The mass of the what? Of the atom of what? A particular what? Element. So that is just how what it is. All right, we move on to question number what? 8. It says the existence of two or more forms of the same element, emphasis on the same element, in the same physical or in the same physical state. Yes, the existence of two or more elements or two or more forms of the same element in the same physical state is known as, remember in the beginning of these past questions, when I started the class, I talked about a concept that is known as what? Allotropy, and I explained what allotropy is all about, right? When we're talking about the allotropes of what? Carbon, which is what? Diamond, and what? The graphite, right? So it says the existence of two or more forms of the same element in the same physical state is known as what? A, allotropy, B, resonance, C, hybridization, and D, what? Isotopy. The correct answer there is what? A, which is what? Allotropy. It is the existence of the what? Same elements in the same what? Physical state, but in different what? Forms. Where in carbon we have the what? Diamond and the what? Graphite, right? Then resonance simply refers to what? Vibrations, right? So resonance are simply what? Vibrations that what occurs when when there's what? A collision, for example, right? So when there's what? A movement, right? So resonance is simply what? Vibrations. While hybridization is simply the mixing or the blending of what? Atomic orbitals to give you a new set of orbitals, which is known as the what? Hybrid what? Orbitals, right? That is what is known as what? Hybridization. Then for isotopy, right? Isotopy is when a particular element or when a same element have the same what? Atomic number but different what? Mass what? Number, right? Which we always know about what we use called chlorine for most of the time. They have the same what? Atomic number, which is Cl what? 17, and the other one we have a mass number what? Cl 1735 and Cl 17 what? 37, right? They have varying what? Atomic what? Masses, but that is not what we are asking here. What we are talking about is what? In different what? Forms, in two or more what? Forms. So the correct answer here is what? Allotropy, right? And that is what? Correct. Number 9 says, in which of the following are radioisotopes used? This is simply talking about what? Radioactivity, right? So it says, which of the following are radioisotopes what? Used? A, treatment of what? Cancer. B, scientific what? Research. C, dating techniques. And D, all of their what? Above. Radioisotope or radioisotopy, which is what? A process, right? Radioisotope is the word term, then radioisotopy is the word continuous what? Process. It can be used in the treatment of what? Cancer. It can be used in what? Scientific what? Research. It can also be used in what? Dating what? Techniques, like carbon what? 14, which can be used to know a particular lifespan of what? A drug, or what? A mummy that was found in what? A tomb, right? This is majorly used by what? Archaeologists, right? For the dating what? Technique. So the answer there is what? All of the what? Above. All of the above can be used, or can be the major uses or the use of what? Radioisotopy, right? Let's move on to the next question, which is question number what? 10. So for this is what? All of the what? Above. For question number 10, the phenomenon observed, right? The phenomenon, the concept observed, right? When dust particles, right? When dust, right? When dust particles, that phenomenon we observe, when dust particles collide randomly, right? Collide randomly. Please note, whenever there's a random collision or whenever there's a random movement of particles, we already know that that is what Brownian what motion, or we already know that that is what Brownian what movement. Now the question here is the phenomenon when that is observed when dust particles collide randomly with each other in a beam of sunlight. Please take note, the beam of sunlight is there to confuse you. The beam of sunlight is there to confuse you because sunlight is what gives us light here on earth, right? So the and we are able to see when there's light, right? When there's a lightning, which is what sunlight. So the beam of sunlight there is just for your what confusion. So remove that beam of sunlight and focus on random collision of particles or the random movement of what particles. So the phenomenon is that when those particles collide randomly in a beam of sunlight is A, the Tyndall effect, right? A, Tyndall effect. B, diffusion. C, osmosis. And D, Brownian movement. The answer is already what Brownian movement or Brownian what motion. For Tyndall effect, from what I have here, it says the Tyndall effect is a scattering of light by colloidal what particles when light scatter. You understand? When light what scatter, when light hit a particular what substance, right? Let's say I point my torchlight, right? And my torchlight is going straight, and in the course of going straight, it meets an obstacle. Let's assume a wall. It meets a wall, so it will scatter. That is what is known as the word Tyndall what effect. And when it scatters, that does not mean it is what undergoing what movement what randomly, right? So this one is what off. Then diffusion, we already know what is diffusion, right? Diffusion is the what movement of what gas particles from a region of what higher concentration to a region of what lower what concentration. Then we also know for osmosis, osmosis must always involve what the presence of what a semi-permeable what membrane, a semi-permeable what membrane, right? So for this, there's nothing like a semi-permeable what membrane. So osmosis is what off, and we have our Brownian motion or our Brownian movement, which is the what the random or the irregular movement of what particles rather colliding with themselves and the walls of their what containers. The answer is what the Brownian one movement or the Brownian what motion, which is option what D, and which is what correct, right? Number 11, the main characteristic features of transition metals, right? The main characteristic features of transition metals are there are. Now we are not just asking you the features of what transition metals. What they're asking is what the main characteristic features of transition what metal. What is that main thing that the moment you see it, you already know that this is what a transition what metal. We have A, they have the same atomic size, right? We have the same atomic size. B, they are reducing agents. C, they forms ion easily. And D, they have variable oxidation what state. A, they have the same atomic size. Do transition metals have the same atomic size? Yes, but although this atomic size at times varies, right? B, they are what reducing what agents. Let me check out for my explanation. They are what reducing agents, but not what all. They are reducing agent, but not what all. And C, they forms ion easily. They form ion easily, but that does not mean the formation of ion easily is their main characteristics. For what we are looking at is their main what characteristics. So the simplest answer or the correct answer is what D, which is what they have variable what oxidation what state. Let's simply use the most popular transition metal, which is what ion. So if you get to find out the ion, or when you get to know about ions, right? When let me clean this so I can have a space to write here. When you hear about ion, we have two types of what ion, right? We have what ion 2, right? We have what ion 2, and we also have what ion what 3. Right, we have our ion 2 and we have what ion 3. So you can find out that this is their oxidation state, right? This is their what oxidation state, and they have variable what oxidation what state, but the same what element, which is what ion, right? This same ion, which is element, have what varying what oxidation what state. So this is the main property, or this is the what main characteristics where we talk about the what transition what metal. So we have our number 12 questions here, and number 12 question says in 1898. In 1898, emphasis on the year, which scientists proposed that the atom is a sphere, right, of positively charged matter in which negatively charged electrons are embedded, right? It says the atom is a sphere, that is a cycle, right? an imperfect cycle is known as what? A sphere, right? It's a sphere of positively charged matter in which negative what charge what electrons are what embedded, are what located, right? We have A here, we have the Ernest Rutherford. B, we have Max Planck. C, we have J.J. Thomson. And D, we have what? Robert Millikan. You already know about the plum pudding principle, right? The plum pudding principle is one that talk about positively charged what matter being what embedded, which is okay. It says it's fear of what negative positively what charged matter in which the negatively what charged electrons are what embedded. And this plum pudding principle was introduced by a particular scientist whose name is what? J.J. what? Thomson, right? So let's get to find out which one here is the correct word answer. We have A, Ernest Rutherford, B, Max Planck, C, J.J. Thomson, and D, Robert Millikan. Like I said about the plum pudding principle, the correct answer is what? J.J. what? Thomson. So let's get to find out why other options are not what? Correct. So number one says, that's for the Rutherford. Ernest Rutherford says, Ernest Rutherford proposed the nuclear model later. Now, Ernest Rutherford also worked on this particular concept, but not exactly this word, yay. You understand? Not exactly this way. He explained the nuclear model later on, and that was in 1911. That was 1911. That was when Ernest Rutherford came and worked on this same what concept, and not in the year 1898. Therefore, Max Planck didn't work on this particular concept. What Max Planck was focusing on was what was known as what? The quantum theory. So Max Planck was not working on this. Max Planck was working on the quantum theory. Then for Millikan, right? Millikan was the one that measured the charge of an electron in his what? The oil drop what? Experiment. It was in his oil drop experiment that this man known as what? Robert Millikan was able to measure the charge of what? An electron, or the charge of what? Electrons, right? So the correct answer here is what? J.J. what? Thomson, while this is wrong and this is wrong and this is what? Wrong, right? So let's move on to the next question. Question number 13. It says oxygen gas is collected in the laboratory. That is the collection of oxygen gas in the laboratory. Oxygen gas is collected in the laboratory by A, the upward displacement of air. So the upward displacement of air, will it enable us to collect oxygen in the laboratory? B, we have the upward displacement of water, which is H2O, and C, we have the downward displacement of water, and D, we have using a gas layer. We are talking about the collection of oxygen not in the industry, rather in the what? Laboratory. So emphasis on what? The laboratory, right? So is it upward displacement of air, the upward displacement of water, or the downward displacement of water, or D, using what? A gas layer? The correct answer there is what? The downward displacement of what? Water. The downward displacement of water is how oxygen gas can be collected in the what? Laboratory. Now, it says that from our explanation we have here, it says oxygen is slightly soluble in water. Note, oxygen is slightly soluble in water and denser than air. So oxygen is denser than air. It is collected by the downward displacement of water in a what? Gas what? Jar. Right? It's collected by the downward displacement of water in a what? A gas what? Jar. So the correct answer there is what? C, which is what? The downward displacement of what? Oxygen. The downward displacement of water. Since oxygen is more denser than air, it will what? Fall down, like it would what I mean is that it will descend, right? While air what? Always what? Is will be what? On top. So the downward displacement of water will enable us what? Collect what? This what? Oxygen in the what? Laboratory. The next question there is CO plus CuO, right? This is copper oxide. Copper oxide plus hydrogen, right, will give us copper plus what? Water. Copper oxide plus hydrogen giving us what? Copper plus what? Water. Now, in this reaction above, copper is what? In this reaction above, what has happened to copper? Now you get to find out that from here we have our copper being attached to oxygen plus what? Hydrogen, which will give us what? Copper now being alone plus what water is being what formed. Now it says what has happened to copper in this what reaction. What has exactly happened to copper in this reaction? And this will lead us to a concept in chemistry that is known as what types of what reaction. And this particular type of reaction that has happened here is not combination reaction, it's not displacement reaction, it is not double displacement reaction. Rather, this type of reaction is known as what? Is known as what? The redox what reaction. And the redox reaction is simply what? The reduction and oxidation what reaction, right? So in the reduction and oxidation reaction, we simply know that reduction, right, is the loss of what? Oxygen, right? Reduction is the loss of what? Oxygen. So let me pause for there and get to our option. It says what has happened to this what copper in this what reaction. We say A, it has been oxidized to copper. So copper has been oxidized to copper, which is wrong, right? It is wrong because oxidation is simply what the addition of what oxygen. Rather, the oxygen here is being what removed, right, to what hydrogen. So it has been oxidized to copper, which is wrong. We have B, it has been chemically converted to copper, which is also what wrong. There's nothing like chemically converted to copper at this particular point in what time, right? C, it has been reduced to copper, and D, it has been reversed to what copper. Now, even though you don't tend to get this particular concept of oxidation and reduction, even using your mere common sense, you get to find out that copper has been what reduced, right? So copper oxide in this particular reaction has been simply been reduced, right? It has been reduced to just what copper. So at this particular point in time, see, this copper, what has happened to the copper is that the copper in this reaction has been reduced to just what copper. So this is just it. Number 15, it says isotopes are atoms of the same element with, I focuses on isotopes are atoms of the same element with, we already know the definition of an isotope, right? It says it's what is an atom, right, of the same what element, right, with the same what atomic what number, but what different what mass. That is what is being what asked here. So let's check. Isotopes are atoms of the same element with the same atomic number. That is number one. A, the same atomic number, different protons. B, mass above 50. C, different what mass. Without wasting much time, we already know that the answer is what? C, different what mass what number, right? We already know the answer is what? C, which is what? Different what mass number. Let me check out for something here right now. Let me check out for something. Okay, so isotopes are atoms of the same element with A, different protons, B, mass above 50, and C, what? Different what mass. If we say different protons, that means the atomic number has automatically what change, right? If we say different what protons, right? So the atomic number will automatically change. And when the atomic number change, that means we are talking about a totally different what element, and we are no longer talking about what the same what element. So, and it must not necessarily be mass above what 50. Right, it must not necessarily be mass above what 50. So the correct answer there is the one with what different what mass. So different mass is what correct. Number 16 says a reaction is said to be equilibrium, or a reaction is said to be in equilibrium when A, the rate of the forward reaction is equal to the rate of the what reversible what reaction, or the rate of the what backward what reaction. B, the rate is what reversible, and C, it does not produce any product. Again, when you say something is balanced, when you say something is equilibrium, it means that the rate of the forward reaction, the way it uses to move forward, is the same way it will also use to move backward, right? So we can simply say the rate of the forward reaction is equal to the rate of the backward reaction. That means that reaction is in what equilibrium. So the correct answer there is what A, the rate of the forward reaction is equal to the rate of the reversible reaction. Now when you say its rate is reversible, it does not make any sense, right? It does not make any sense in the concept of a balanced equation. You understand? So it does not make any sense. The rate is reversible does not make a complete sense in this aspect. Then it does not produce any product. Again, when we say something is in equilibrium, we are not saying it will stop production or it will stop production of a product, right? What we are simply saying is that it is balanced, right? We are not saying it's going to stop production, right? But what we are saying is that it is balance, that the same speed or the same movement it used to go forward is the same way it can also use to go backward. So we are not simply saying it will not produce any product again. So for this, the correct answer is what? A, the rate of the forward reaction is equal to the rate of the reversible or the backward reaction. Number 17, it says the boiling point of a liquid such as methanol is the temperature at which A, its vapor pressure is equal to 1 atmospheric pressure. This is correct, and Surprisingly, this is the only option we have here for this question. This is the only option we have here for this question, and it's automatically what? Correct, right? The boiling point of a liquid such as methanol is the temperature at which its vapor pressure is equal to what? 1 atm. And we already know the full meaning of atm as science students. We already know that atm is simply what? Atmospheric what? Pressure, right? So move on to question number 18. It says alkenes and dash, right? Alkenes and dash are compounds that contains multiple bond each, right? Alkenes and dash are compounds that contain multiple what? Bond each. We have A, alkanes, we have B, benzene, we have C, alkynes, and we have D, what? Benzaldehyde, right? So when we say A, we are talking about what? Multiple what? Bond. We already know that alkanes are what? Hydrocarbons with what? Single what? Bond, right? So alkanes is not going to what? Fall into compound that contains what? A multiple what? Bond. So when we say benzene, benzene is already here. This is to tell you that benzene has what? Two what? Benzene is what? Has what? A two bond, right? Benzene has a two bond, and alkenes is already here, telling you that alkenes are compounds with what? Two bonds. So the benzene and the alkenes are falling together, and the benzene is not does not have the word power to fall into the word dash that is here, right? So we move on to the next one, which is what? Alkynes. Alkynes are what? Hydrocarbons with what? Triple what? Bonding, right? And the benzaldehyde. Benzaldehyde does not fall into this word component or into this particular stuff we are talking about. So in other words, the correct answer is what? The word alkynes, which is what? C. Emphasis is on multiple word bond. We are not talking about what? Two bond, or we are not talking about what? We are not talking about double bonds. Neither are we talking about what? Triple bonding, right? What we are talking about is what? Multiple. We already know what is multiple, right? Two and what? Above, right? So it says alkenes and dash are compounds that contains a multiple bond each, right? So the correct answer there is the word alkynes, which is what? A triple word bond. We have question number 19 here on the board. So the question says dash is due to the formation of hydrogen gas, right? Dash is due to the formation of what? Hydrogen gas bubbles around the copper of a simple what? Cell. Dash is due to the formation of hydrogen gas bubbles around the copper of what? A simple what? Cell, right? A, we have what? Polarization. B, we have what? Depolarization. C, we have what? The local action. And D, we have what? Amalgamation, right? The question is talking about what? The formation of what? Hydrogen gas bubbles around the copper of what? A simple what? Cell, right? So our answer, which is what? We have A, polarization, B, depolarization, C, local action, and D, what? Amalgamation. So I'm going to take from the one that is what? Wrong. So automatically our what? D is what? Wrong. Amalgamation is not what? The correct word answer, right? Amalgamation is simply the addition of metals to mercury, right? That is what that is what amalgamation is all about. The addition of what? Metals to what? Mercury is what is known as what? The amalgamation. Then for local action is simply what? Unrelated to the concept of what? The formation of what? Hydrogen gas bubbles around the copper of what? A simple what? Cell, right? So this particular word option here is also what? Unrelated, right? So we have our word depolarization. If you get to notice, I'm taking from which that is wrong to which that is what? Correct, right? We have our word depolarization, right? Depolarization is simply the removal of this word hydrogen word gas word bubbles. So in essence, the correct answer is what? A. Polarization is simply the word formation of what? Hydrogen gas bubbles around the copper of what? A simple word cell. That is what is known as what? Polarization. So in this concept, our correct answer is A, which is what? Polarization, right? We move on to the next question, which is question number 20. It says the properties of electrovalent compound. So what we are looking at is what? Bonding, right? And the type of bonding we are looking at in particular is what is known as the word electrovalent word bond, right? Not fully well now the electrovalent bond is also known as the word ionic word bond, right? So we say the properties of these ionic bonds, right? These compounds that would undergo what? Ionic word bonding, which is known as what? The electrovalent bonding, and which we already know that the electrovalent bonding simply involves what? The total transfer of what? Electrons, right? So it includes the following except. So we are looking at what? Exception. So you simply have to get the what? Characteristics of what? Electrovalent what? Compound or electrovalent what? Bonding, right? So number one, A, here we have what? High melting and boiling what? Point. Is high melting and boiling point not a characteristic of what? Electrovalent bond? B, we have what? Conduction of what? Electricity in the molten what? State. C, we have what? High volatility at room temperature. And D, we have what? Ionization in what? Aqueous what? Solution. Our correct answer there is what? C, right? Is the following except. So the exception here is simply what? High volatility at what? Room temperature. Knowing fully well that our electrovalent compounds exhibit what? High melting and boiling what? Points. They also conduct what? Electricity in the what? Molten state, and they also ionize completely in what? Aqueous what? Solution, right? So talking about the what? High volatility at room temperature of electrovalent compound doesn't stand the test of time because electrovalent compound are being held by what? Strong what? Electrostatic what? Force, and this strong electrostatic force prevents them from exhibiting what? The property, or exhibiting what? The exhibiting the property that is known as what? Volatility, right? So this particular volatility is a what? Exception of the what? Properties of what? Electrovalent what? Compound. Question number 21 says, which of the following statement is not correct about what? Electrolysis. Which of the following statement is incorrect when we are talking about what? The concept of what? Electrolysis. We have A, reduction occurs at the anodes. B, anions migrate to the what? Anodes. C, positive ions migrate to the cathodes. And D, concentration affects the discharge of what? Ions, right? The question is, which of the following statement is incorrect when we are talking about the concept of what? Electrolysis, right? The correct option there is what? A, right? So the correct option there is what? A. Reduction, when it comes to electrolysis, reduction, please note, reduction does not occur or does not happen at the what? Anode. Reduction occurs at the what? Cathode, and oxidation occurs at the anode. Please take note of that. Reduction occurs at the cathode and oxidation occurs at the what? Anode. But seeing it here, it says reduction occurs at the anode, automatically makes it an exception, right? Because the question is, which of the following statement is not correct? So the only statement here that is not correct is the word reduction occurs at the what? Anode, because positive ions migrate towards the what? Cathode when it comes to what? Electrolysis. So the correct option there is what? A. Please, it is very, very important that you take cognizance of this, everything I'm saying here. Take note of it, and if you want more knowledge, you can go and read from your textbooks. And if you love this video, please don't forget to hit on the red subscribe button, right? So we move on to the next question. Separation of mixtures. So basically we are talking about separation, right? Separation of mixtures of solids. So this is what? Mixtures of what? Solid. Emphasis on what? Solid. By physical what? Method. Separation of mixtures of what? Solid by physical method can be based on differences in the following, except. Separation of mixtures of solids by physical methods can be based on the differences in the following, except. So what they are asking us here is what? Except. So which of these here in this option is going to be what? Wrong, right? So we have A, melting what? Points. We have B, solubility. C, we have their particle size, and D, we have their what? Molar what? Mass. Note that we are talking about what? Separation of what? Solid, and we are not just talking about the separation of what? Solid. We are talking about what? The separation of solid using their what? Physical what? Method, right? Using the physical what? Method. So melting point is something we can see, right? So the melting point is a physical method where we can be able, which we can use to distinguish between two types of what? Solid. We also have their what? Solubility, how they are able to what? Dissolve or what? Become what? Soluble in the presence of what? A solvent, right? We also have their various what? Particle what? Sizes. The incorrect option here, or the correct option for this, right? Following from the word question, the correct answer here is what? D, which is what? Molar what? Mass. Molar mass is not what? A physical what? Method. Molar mass is what? A chemical what? Method. So the correct option here is what? D, which is talking about the what? Molar what? Mass, right? We'll move on to the next option here. We have question number 23. It says the following are major gaseous pollutants. Emphasis on the following are what? Major what? Gaseous what? Pollutants. Emphasis on what? Major. right? They are not just talking about whether they are gas pollutants or not. We are looking at the major gaseous pollutant, except, so which of these here is not going to be what a major what gaseous what pollutant, right? So we have our number one, which is what CO. We know that our CO is what the carbon what mono what oxide, right? We have our what CO2, which is our what our what carbon what dioxide, and we have our what sulfur what oxide, and we have our CFC, right? Our CFC simply means what the chlorofluoro what carbon, right? So our CFC simply means our fluorocarbon. Now the question is, the following are major gaseous what pollutant except carbon monoxide, carbon dioxide, sulfur oxide, and what chlorofluorocarbon. The correct option there is what D, which is what the chlorofluorocarbon, right? So why is it that the fluorocarbon is not what a major gaseous pollutant, and why is it that the other options are major gaseous what pollutant, right? So from here we say, or we have here that our what do you call it, we already know that carbon monoxide is what toxic, right? You have been hearing about death, right? So carbon monoxide is very, very what toxic, right? Then causes what carbon dioxide causes what greenhouse effect, and our sulfur what dioxide causes what, or our sulfur oxide causes what acid what rain. The acidic what rain is caused by what sulfur what oxide, and our carbon dioxide causes what greenhouse effect, and our carbon monoxide is very, very what toxic. So all this makes them what major what gaseous pollutants. So the only exception here we have is our what CFC, which is the what the chlorofluoro what carbon. Question number 24. Brass is an alloy, right, containing copper and dash. Brass is an alloy containing copper and dash. A, zinc, B, tin, C, silver, and D, which is what lead or lead as we may pronounce it. A, zinc, B, tin, C, silver, and D, what lead. A brass is an alloy containing what copper and what zinc. That is the what alloys of what brass. So it is what brass is an alloy containing copper and what zinc. So zinc, which is what A, is the what correct what option, right? So that is just how it is. Brass is an alloy containing what copper and what zinc. We have the next question, which is question number 25. It says, which of the following reduces the activation energy? So which of the following reduces what activation what energy? We already know that activation energy is the minimum what amount of what energy that is what required before what a chemical reaction will take place, right? So we have A, freezing mixtures, B, we have reducing agent, C, we have water, and D, we have what catalyst. It is only a catalyst that can reduces what activation what energy, right? Catalyst lowers the what activation energy in order to speed up the what reaction. So the correct answer here is what D, right, which is what the catalyst. So it is not reducing agent that is going to reduce the activation energy of a chemical reaction. Neither is it water, or neither is it going to be what freezing what mixtures, right? Move on to the next question, which is question number 26. It says, in the electrolysis of brine, right, this is what brine what electrolysis, the anode is A, carbon, B, platinum, C, zinc, and D, what copper. In the electrolysis of what brine, right, the anode is what carbon, right? The anode is what carbon. So it is not what platinum, rather is it what zinc and what copper. Platinum is very, very what expensive. Let me show what I have it here, right? In the electrolysis, the anode is made of what carbon. The reason is because carbon is what inert, and it is used as what an anode, including what production, right? Then the platinum, they say it's expensive, and something that is expensive is not what typically what used. Then for the zinc and copper, it is said that the zinc and copper will not what dissolve, so they are not used as what anodes when it comes to the what brine what electrolysis, right? We move on to the next question, which is question number 27. A brand of ink, right, containing copper 3, copper 2, and what iron what 2 what ions, right? When I was talking about separation technique in my videos, when I was preparing people for JAMB, when I was talking about the separation technique, I said the moment you hear ink, the only type of separation technique that should come to your mind, the moment you hear the concept of ink, should be what is known as what chromatography, right? So let me clean this and show you something. right? So let me just clean this. So let's check up the option first. We say a brand of ink contain what? Copper what 3, copper what 2, and what? Iron what 2 what? Ions can best be separated into each of its what? Various components by A. Fractional crystallization, wrong. B. Fractional what? Distillation, wrong. Fractional crystallization is the what? Separation of what? Crystals, right? Then for fractional distillation is based on what? Their boiling what? Point, right? Then the sublimation is when what? Solid, right? Solid changes directly to the what? To the gaseous what? State. So the correct answer here is what? Chromatography. So let me tell you something, or let me talk about the aspect of what? Chromatography, right? Chromatography is a separation technique that is based, the moment you hear things like ink, the moment you hear anything about ink, right, and the moment you hear anything like spit, right, the moment you hear anything about spit, the moment you also hear anything about rate of migration. So you see rate of what? Migration, right? Rate of what? Migration, right? This is what talking about what? Chromatography. Chromatography is the only separation technique that involves what? These three terms: ink, speed, rate of migration, and also colors, right? It's also involve what? Colors. Can also involve what? Dyes, right? So the moment you hear dyes, colors, rate of migration, their speed, and or when you hear the concept of what? Ink, note that the only separation technique that will best fit in is known as what? Chromatography. Question number 28 says compounds that have the same molecular formula but different structures are said to be A. Allotropic, B. Isotopic, C. Polymeric, and D. What? Isomeric. We already know what is what? Allotropy, right? The ability of a compound to exist in the same what? The ability of a same compound, right, to exist in what? In different form but in the same what? Physical what? State. They exist in what? Different forms but in the same what? Physical what? State. And popular example we always talk about is what? Carbon what? Allotropy, right? B is what? Isotopy. We already know what is what? Isotopy, right? Isotopy is when elements have the same what? Atomic what? Number but different what? Mass number. Then polymers, which is also known as what? Polymeric, right? Is polymers are simply what? Large what? Repeating what? Unit, right? So polymers are simply what? Large repeating unit. We are only left with the correct option, which is what? D, which is what? Isomers, which is what? Isomeric. So we say those compounds are said to be what? Isomeric. We have question number 29. It says if an element has the electronic configuration of 1s2, 2s2, 2p6, 3s2, and 3p4, such an element is said to be a metal, B. Alkaline earth metal, C. S block elements, and D. The P block what? Element. Now, if you get to check the electronic configuration, we have our 1s, we have our 2s2, we have our 2p6, 3s2, and our 3p what? 4. Such an element that exhibits such an electronic configuration is said to be what? A p block what? Element. Is said to be what? A p block what? Element. So the correct option there is option what? D, right? And we move on to the last question for this Post-UTME what? Online what? Practice, right? So we are going to end with this, and what we have here is question number 30. It says 300 cm cube of a gas has a pressure of what? 400 what? Millimeter what? Mercury. If the pressure is reduced to what? 150 what? Millimeter mercury, find its what? Volume. This is simply what? Gas what? Laws, right? This is simply what? Gas law, and this gas law is the what? Boyle's what? Law, where we have the what? We have our volume, we have our pressure, and we have our pressure, but we don't have our second word volume. We already know our Boyle's law, right? So our Boyle's law here is what? The P1, right? P1 what? V1, right? Is equals to what? P2, which is what? V what? 2, right? So we basically have our P1, right, which is our pressure, our first pressure, to be what? 400 what? Millimeter what? Mercury. To make this class going to be spicy, I'm going to just list down this unit for you. I'm going to list out the variables we have here, and you are going to solve it and drop the answer in the comment section. Let me actually know whether you followed up from the beginning of this class to this very section. So I have our P1, which is our first pressure, to be at 400 millimeter mercury. We have our volume, our first volume. This is what we have our P1 equals to our 400 millimeter mercury. We have our V1 to be our 300 cm cube, and we have our P2 to be at what 150 millimeter mercury, and our V2 is what unknown. So basically what we are looking for is our what V2. I've listed out the variables for you, so now solve it and drop the answer in the comment section, and this will enable me know that you have really followed the class from the beginning of this lecture, which I talked about from number 1 to number 30. If you love this video and you wish to continue getting videos like this, please don't forget to hit on the red subscribe button, and also share this video to your friends so that they can come here and get value, and in turn I'll feel motivated to continue dropping videos like this. Note, these are just some of the practice questions which are also seen as the possible questions which keeps repeating themselves in almost all the post-UTME for the past years. Whether you're in the University of Calabar, OAU, UNIBEN, UNILORIN, you will surely get to see questions from what I have just did here. You can get a copy of this post-UTME past question for just 1,000 naira. Chat me up on WhatsApp, request for it, and I will drop my WhatsApp number. Chat me up on WhatsApp and you will get the post-UTME questions which will really enable you prepare well and smash your post-UTME. Note, your JAMB score is not enough, and your post-UTME score can propel you in order to enable you secure your mission to study your dream course and in your dream university. Until I see you in my next video, always remember that you're wonderful, always remember that you're unique, and always remember that you're a pace setter. I really love you. Thank you.